Hey guys, today we're going to talk about another method for solving systems of equations using substitution. And substitution is a method of solving a system of equations by taking what is known from one equation and putting it into another equation. So we don't have to actually graph the two functions to find out where they will intersect. We can use the substitution property of equality. And the substitution property of equality is as follows. So if I know that A equals B, and I know something else about A, like A plus 7 equals 12, then I can replace or substitute what I know about A with B. I can replace A with B if I know they are equal. So if A plus 7 equals 12, then I know that B plus 7 must equal 12. I can replace or substitute those two quantities, A and B, if I know that they're equal to each other. And I give a quick, simple example here of what I mean. I know that 8 is equal to 4 plus 4. So anywhere there's an 8, I can substitute a 4 plus 4 and it will still remain equal. So I know that 8 plus 2 is 10, and I know that 8 is the same as 4 plus 4. So I can replace 8 with 4 plus 4 and get 4 plus 4 plus 2 equals 10, which is true. So this is just the basic idea behind what we're going to be doing algebraically to solve our systems of equations. So how do we use substitution to solve systems? The first thing we're going to do is solve one of the equations in our system for one of the variables, either x or y. It doesn't matter which one you choose. My advice would be to pick the easiest one to solve for. Get one of the variables all alone so we know what it equals. Next, we're going to substitute what we know about that variable into the other equation. We're going to replace it with what we know about it. And then what we end up with is an equation that only has one variable now. There's not two variables anymore. And then we can solve that equation using the skills that we learned in the last chapter. So then we can solve it and find out what the value of that variable is. We can find out exactly what either x is or what y is. And then we can use that to find the value of the other variable if needed, if we don't already know it by then. So after all of that, we will know our x value and we will know our y value. And that will be the location where these two would be, these two equations would be equivalent, or where the lines would cross on their graphs. So let's take a look at an example here. I've included the graphs of these functions just to give you a comparison of what we're trying to find here. So here's a system, y equals 5 and y equals x plus 4. We want to know where these two cross, or where they're equal at the same time. And we can see on the graph where that is, but I want to show you what that looks like algebraically. We're going to use the substitution property of equality here. Now in this first statement, I know that y is equal to 5, and I'm going to use that fact. I know that y is equal to 5. So in this second equation, I can replace y with 5, since I know that y is equal to 5. So I will do that and replace it with 5. And I get 5 equals x plus 4. Now I have an equation that I can solve for x, and I can find out what x is. Subtract 4, and you get x equals 1. Well, we already know that y equals 5, and now we know that x equals 1. So where they cross is at 1, 5. X is 1, y is 5. And then we can confirm that on our graph here, that is where they cross. They cross at 1, 5. So you can see graphically it agrees with what we did algebraically. So we really don't need to graph them to find out where they cross. We can solve them algebraically. Let's take a look at this one. The first equation, y equals 7 minus x, and the second equation is x equals 3. Well, in the second equation, we're told what x is. So I already know that the x value where they cross is going to be 3. And I'm going to use substitution. Since I know that x equals 3, I can replace x in the other equation with 3. I can substitute, and I get y equals 7 minus 3. Well, that's 4. So I know that y is equal to 4 when x is 3. So I know that these two lines will cross at the point 3, 4. And again, if you look at the graph, you can see that agrees with what we came up with. This is the point 3, 4. So the solution to this system is 3, 4. Here's a little bit more complex system. Here we don't automatically know what one of the variables is, and we don't have a variable alone. So we're going to have to do a little bit of work on this one. We're going to have to do a little bit of algebra to find out the solution to our system. So what I do is I look through all of the terms with variables in it, and I ask, which one would be the easiest one to solve for? Which one can I get by itself the easiest or the quickest? And I look at this 2x, and I'm going to have to add 3y and then divide by 2. Or I look at the 3y, and it's got a negative in front of it. I look at this x, I'm going to have to subtract y and then divide by 4. And then I look at this right here. That's almost by itself. I can do this in one step and get y by itself. So this is the variable I'm going to choose to get by itself or to solve. So I'm going to just choose that one. I mean, just because it's the easiest. I could have done literally any of the variables, but this one's going to be the easiest one. So I'm going to get the y by itself in this equation by subtracting 4x from both sides. And I get 1 minus 4x equals y. So now I know what y equals. I mean, I don't know the number, but I know that y is the same as 1 minus 4x. So I'm going to use substitution to find out what x is. I know that y is equal to 1 minus 4x. So I'm going to replace or substitute that into the first equation. So I'm going to replace y with what I know that it is equal to. And I'm going to get this equation right here from the first one, 2x minus 3 times, now it's 3 times y in the first equation, but I'm going to replace it with what I know it equals. I know it equals 1 minus 4x. So I'm going to replace or substitute 1 minus 4x in the place of y. So now I get this equation, and you'll notice there's only one variable in this equation now. Now I can solve this. And it might take a little bit of work, but I can still solve it. So I need to do the distributive property here, and I get 2x minus 3 plus 12x equals negative 10. Combine my like terms. 14x minus 3 equals negative 10. And now this is a two-step equation that I can solve. Add 3. 14x equals negative 7. And then I'm going to divide by 14. X equals negative 1/2. So I know the x value of my solution is negative 1/2. And looking at my graph, that kind of makes sense right there. Here's negative 1/2 for x, and now I just need to find out the y value. Well, how do you find out the y value once you find out the x value? I know that x is equal to negative 1/2. Now I can literally plug negative 1/2 into any of these equations here that I have. And I'm going to choose this one right here since it'll probably be the easiest one for me. I know that y is equal to 1 minus 4 times x. 1 minus 4x equals y. And again, I'm just pulling that from right here, this equation that I got that told me what y is equal to. And I know that x has to be negative 1/2, so I'm going to put negative 1/2 into that equation, and I'm going to find out what y equals. Well, 4 times negative 1/2 is negative 2. 1 minus negative 2 equals y, and 1 minus negative 2 is 3. So the y value is 3. The x value is negative 1/2. There is the point that they cross, and that is confirmed right there. Y equals 3. X equals negative 1/2. So a little bit of algebra to do, but again, it eliminates the need to graph these functions, especially when you have a fraction answer. It's kind of hard to tell accurately from the graph where they cross. Algebraically is much more accurate. Let's take a look at this system here. Again, none of the variables are alone, so I need to figure out which one I want to get alone. And looking at these, trying to find out the one that is the easiest to get by itself. Now this second equation, I'm going to avoid this one because I know I'm either going to have to divide by 3 or divide by 5 to get these variables alone. And I'm going to avoid that because these numbers are not divisible by 3 or 5. In the first equation, all of these are divisible by 2. And so that means I want to get my x by itself, because I'm going to have to divide by 2 eventually to get x by itself, and all of those numbers are divisible by 2. So I'm just going to go ahead and do that. So I'm going to take that first equation, 2x minus 4y equals 6, and I'm going to solve this for x. I'm going to get x by itself. So I'm going to get rid of the y term by adding 4y, and I get 2x equals 6 plus 4y. And I'm going to divide both sides by 2. And that gets me x is equal to 3 plus 2y. And that worked out nicely because I don't have any fractions or decimals now, because everything was divisible by 2. So I know now that x is equal to 3 plus 2y. And I'm going to take that and substitute it into the other equation. I'm going to replace x with what I know it equals. I know it equals 3 plus 2y. So that is going to get me 3 times 3 plus 2y, again replacing x with what I know it equals, minus 5y equals 3. And now again, I have an equation that only has one variable. I need to solve this, so I need to use the distributive property. 9 plus 6y minus 5y equals 3. Combine my like terms. 9 plus 1y, or y, equals 3. And then subtract 9. Y equals negative 6. So here I have found the y value. The y value is negative 6. So these two lines are going to cross at something negative 6. And again, we can see that that's true right here, that the y value is negative 6 where they cross. Now I just need to find the x value. And again, I can use any of these equations here. I can use this equation that I got, or I can use any of the original equations and use negative 6 as the y value to find out what x is. But this one's going to be the easiest one right here. So I'm going to go ahead and use that one. X equals 3 plus 2 times y. And I know that y is negative 6, so I plug that in. X equals 3 plus negative 12. X equals negative 9. And there's my x value. These two lines will cross at negative 9, negative 6, and that is indeed where they cross. So I found it algebraically, not graphically. Now let's take a look at these two, and we saw that when we were graphing solutions to systems, that sometimes we graph the same line. And you can tell from the graph that these two are actually the same line. So what does that look like when we try to use substitution? How does that turn out when we're not graphing it and we can't see immediately that these are in fact the same line? Well, fortunately, this one is already solved for y. I know what y equals, so I am going to plug what I know about y into the first equation. 4x plus 2 times negative 2x plus 4 equals 8. 4x, and then again distributive property here, minus 4x plus 8 equals 8. And you may have noticed that these two terms are going to eliminate. That's 0. And all I'm left with is 8 equals 8. And you'll recall when we were solving equations with variables on both sides, and then when we had the variables eliminated, okay, there are an infinite number of solutions here. Infinite number of solutions. These are the same line. So just like when we were graphing and we came up with the same line, we notice that we come up with a true statement here, 8 equals 8. That's an infinite number of solutions. These are the same line. And again, here we have to run into that other situation. Well, how do we know if we've got parallel lines if we're not graphing them? What's that going to look like algebraically? Well, I'm going to have to solve one of these, and I'm just going to solve the second one for x because that's pretty easy to do. I'm going to add y to both sides, and I get x equals 1 plus y. And I'm going to take what I know about x and plug it into the other equation. So 1 plus y minus y equals negative 4. And again, you see that my y values cancel each other out. Positive y minus y, 0, and I get 1 equals negative 4. Well, that's a false statement. So that is never true. So there is no solution. So algebraically, we see that these are going to be parallel. When you come into a false statement or you eliminate one of the variables and it's false, we're going to have no solution.